This is a video about rates, ratios, and proportions. We'll start with talking about what a ratio and a proportion is. A ratio is a comparison of two quantities using division. So if we were going to talk about the ratio of 3 to 4, what we would do would we would take 3 and we would divide it by 4, like a fraction. The other way you can write a ratio is you can write it with a colon. So 3 and then a colon is those two dots, like this. This both means 3 compared to 4 using division. So 3 divided by 4 is 0.75. On the other hand, a proportion is an equation that states that two ratios are equal. So I could say that the ratio of 3 to 4 was equal to the ratio of 6 to 8. This would be a proportion because we're looking at two ratios that are equal. These are equivalent fractions because if you divide 3 by 4, you get 0.75. Same thing happens if you divide 6 by 8, you get 0.75, and it reduces to 3/4. You can use ratios and proportions to solve a lot of different types of problems. For example, the ratio of teachers to students at a local high school is 1 to 15. There are 675 students at the school. How many teachers are there? Now, of course, with any problem, we're going to start by defining our variable. So the first thing I'm going to do is notice that the question asks, how many teachers are there? So I'm going to write down that x is the number of teachers. After we define a variable, the next step is always to write the equation. And in this case, the equation will be a proportion. So, since a proportion is two ratios set equal to each other, we need to find two ratios. The problem should tell you one ratio. For example, in this problem, it tells you that the ratios of teacher to students is 1 to 15. One teacher for every 15 students. So I'm going to start out by saying that 1 to 15 is our first ratio, and that needs to be equal to another ratio. And it needs to be the same type. It needs to compare teachers on the top to students on the bottom. So we need to write another ratio of students to teachers. Now, in this case, we're going to have our variable come into play. So we don't know another number of teachers, so I'm going to put the x up there. We do know another number of students. We know that there are actually 675 students, so that's going to go on the bottom. One teacher for every 15 students, actually x teachers, actually 675 students. Now that we have a proportion which should have x in one place and numbers in the other, our next task is going to be to solve. And to solve a proportion, we do something called cross-multiplying, which means we multiply the numbers or variables on the diagonals of the proportion. So we're going to multiply 15 times x, and that's going to go on one side of the equation. Here's 15x. And we're going to multiply 675 by 1, and that's going to go on the other side of the equation. So now we no longer have the fractions, but a regular equation. At that point, we solve like we normally do, so that means dividing by 15 on both sides to get x equals 45. And as always, our final step will be to answer the original question, which is to say there are 45 teachers. 45 teachers for 675 students is the same thing as one teacher for every 15 students. Ratios and proportions are also the way that you figure out how big things are on a map. Maps always include something in the bottom corner called a scale, which tells you how big things on the map are, so in this case 1 inch on the map, in comparison to how big things are in real life. So this is, in other words, a ratio. It's comparing sizes on the map to sizes in real life. So in this problem, they tell us that the distance on the map between Dallas and Houston is 1.25 inches, and they want us to find the actual or real life distance. So we need to start with the ratio we know, and in that case, the ratio we know is the scale. 1 inch on the map for 180 miles in real life. And we need to set that equal to another ratio of inches to miles. So what we know is that on the map, Dallas and Houston are 1.25 inches apart, and what we don't know is the actual distance in miles in real life. So 1 over 180 equals 1.25 over x. Now we cross multiply. and you get x equals 281.25. So our final answer is the actual distance is 281.25 miles. Now we're ready to look at some rates, and we're going to be looking at something called a unit rate. So a rate is a comparison of two quantities with different units, like miles per hour or miles per gallon or feet per second. So we're comparing different things. And when we're talking about a unit rate, what we're doing is we're making the second quantity have only one unit. So miles per 1 hour that you travel, or how many miles your car gets per 1 gallon. So here's what you need to know about unit rates. First of all, a rate. So you might compare the number of miles that you drive in a certain number of hours. When we're talking about a unit rate, what we're talking about is the second quantity being only one of them. So when we're talking about a unit rate, we would be saying miles in 1 hour. So here's why this would be useful. This problem tells us that the winner of a hot dog eating contest ate 53.5 hot dogs in 12 minutes, which is gross, but that's neither here nor there. We need to do the problem. So this problem is telling us that the person who won this contest ate 53.5 hot dogs in 12 minutes. If we're looking for a unit rate, we want to know how many hot dogs they ate in 1 minute. So for a unit rate, you're always looking for the number of things that happened per second, whatever that second quantity is. So if we're talking about something that happened in minutes, instead of 12 minutes, we want 1 minute. So I'm going to make my x hot dogs eaten in 1 minute. If I cross multiply, on one side I get 12x, and on the other side I get 53.5. And if I divide, I get x equals 4.46. So that's the number of hot dogs that were eaten in 1 minute. So our unit rate is 4.46 hot dogs per 1 minute, or per minute. So you don't have to say per 1 minute. You can just say per minute, and we'll assume that we mean 1. Before we finish up, we're just going to take a look at solving a basic proportion out of context. No problem, no words, just a basic equation that we need to solve. So we know that anytime we solve a proportion, we cross multiply. So in many situations, that's really easy. For example, in this diagonal, 5 times x is definitely 5x. But what you need to be careful of is on this diagonal. When we're multiplying the 2 times the 3x plus 1, that needs to get multiplied by the 3x and the 1. So what you need to do is put that 3x plus 1 in parentheses. Once you've done that, this is a normal equation with variables on both sides. We'll start by distributing. To get 6x plus 2 equals 5x, I'll subtract 6x on both sides, divide by negative 1 to isolate the x, and get for a final answer x equals negative 2. Now that we've finished with rates, ratios, and proportions, there are 2 problems for you to try. You should do these in your notebook and be ready to give your answer and discuss them. Best of luck.